Today we will discuss about zeroth chapter of physics, that is mathematical tools. Students, you generally know about T ratios. Sin theta, cosecant theta, that is inverse of sine, cos theta, secant theta, that is inverse of cos, tangent theta and cotangent theta, that is inverse of tangent theta. Also, you know their values. For example, this table is very familiar. If you find out the value of sine 30 degree, you will say 1 by 2. If you want to calculate the value of cos 45 degree, you will say 1 by root 2. And if you want to calculate the value of tangent 0 degree, you will say it's 0, or tangent 45 degree 1. And you also know all the values ranging from 0 to 90 degree of the angle. What about if the angle is increased or angle is 120 degree? For example, I ask you the value of sine 120 degree, cos 150 degree, or tangent 180 degree, or other values which do not lie in this table. Then you have to use this particular formula. Let us divide a 360 degree angle into 4 segments, equal segments, 0 to 90 degree, 90 to 180 degree, 180 degree to 270 degree, and 270 degree to 360 degree or 0 degree, means completing a cycle from 0 to 360 degree. First quadrant, second quadrant, third quadrant, and fourth quadrant. Remember a sentence: add sugar to coffee. A stands for all: sine, cos, tangent, cotangent, secant, cosecant. S stands for sine and its inverse, that is cosecant theta. T stands for tangent and its inverse, cotangent theta. C stands for cos and its inverse, secant theta. Means if we are in first quadrant, we will write the formula all. So A means all. So all are positive in first quadrant. Means if you are considering 0 to 90 degree, in first quadrant 0 to 90 degree, remember all quantities, all T ratios are positive. If you are in second quadrant, the second symbol is sugar. First letter is S, sine and cosecant. Means in second quadrant, means 90 to 180 degree, only sine and cosecant are considered positive. Other all negative, means cos, tangent, cotangent, secant will be negative in this quadrant. Means in second quadrant 90 to 180 degree, only sine and cosecant are positive. If we go to third quadrant 180 to 270 degree, then we will remember it by symbol T, that is tangent and cotangent is positive. Other cos, secant, sine, cos are negative. Means in third quadrant for 180 to 270 degree, tangent and cotangent are positive, rest are negative. And in the last quadrant, we are using the symbol coffee. C stands for cos and its inverse secant. So in fourth quadrant 270 to 360 degree, cos and secant are positive, tangent, cotangent, sine, cosecant are negative. So fourth quadrant 270 to 360 degree, cos and secant are positive, others are negative. This is the rule number 1 which you must remember: add sugar to coffee. A for all, S for sine, T for tangent, and C for cos. Second rule is this: whenever in operation 90 or 270 is coming, means if we are adding sine 90 plus 30, or we are adding sine, cosine, tangent, or any other quantity, there comes 270 plus 30, 60, or minus 270 minus, then always remember, then co will change. Means if it is sine, it will be converted to cos theta. If it is cosine, then it is sine theta. If it is tangent, it will change to cot theta, and if it is cot theta, it will be changing to tangent theta. If it is secant theta, it will change to cosecant theta, and if it is cosecant theta, it will change to secant theta. Consider some examples. For example, we want to calculate the value of sine 150 degree, that is 180 minus 30 degree. 150 lies in the second quadrant, 90 to 180, and in second quadrant all t ratios are positive, so sine is positive, so introduce a positive sign. Second thing is, there is a no 90 or 270 in the operation, so co will not change, so it will be sine of 30 degree. So sine 30 degree, you can calculate the value from the table, it is 1 by 2. Consider another example. Cos 180 plus 30 means cos of 210 degree, which is in the third quadrant, 180 to 270, and in third quadrant tangent and cotangent are positive, so cos will be negative, so introduce a negative sign. It will be cos of 30 degree because 90 and 270 are not in the operation, so same sign will appear, same t ratio will appear. If it is cos, it will remain cos, and cos 30 degree you can calculate from the table. There is a one more example. Tangent of 270 plus 30 degree, this is tangent of 300, that is in the fourth quadrant, 270 to 300 degree. So in fourth quadrant cos and secant are positive, so definitely tangent is going to be negative, so there comes a negative sign because of it's lying in the fourth quadrant. Again here it is 270 degree in operation, so co will change, means tangent will be converted to cotangent of the angle. So tangent 270 plus 30 degree will be equal to minus of cotangent 30 degree, that is minus root 3. Consider one more example. Cot 90 plus 30 means 120, 90 to 80 second quadrant, sine and cosecant are positive, so cot is negative. 90 is the in operation, so co will change, it will change from cot to tangent, so it is minus of tangent 30 degree, and you can calculate the value of tangent 30 degree from the table. So you can also calculate other values, for example sine 120 degree, cos 120 degree, tangent 120 degree. Consider one more example, sine of 225 degree. Let us do it in two different ways. 180 plus 45 degree, 270 minus 45 degree. 180 minus 180 to 270, third quadrant, tangent cotangent positive, sign will be negative. So in both the operations, here and here negative sign will come. 180 degree is there, so no co will change, sign will remain as sine of 45 degree. 1 by root 2 minus 1 by root 2 is the value, and here 270 is there, so co will change, sine to cos, so it is minus cos 45 degree, it is minus 1 by root 2. There is a no change in the value, value is minus 1 by root 2 either in this way or in this way, so sine 225 degree is equal to minus 1 by root 2. There are two more examples which are very common, sine 180 degree and cos 180 degree. This is sine 90 plus 90. 90 is there, sine will change to co, and it is in third quadrant is starting here. Tangent and cotangent are positive in third quadrant. Sine is negative here, so its value will be minus of cos 90 degree, and cos 90 degree is 0. Again cos 180 degree, third quadrant starts here, tangent cotangent are positive, cos is negative, so co will change cos to sine. So cos 180 degrees minus sine 90 degree, and that is minus 1. Remember sine 180 degree as 0 and cos 180 degree as minus 1. Let us discuss now nature of graphs. Let us plot a graph between y and x, where y has power 1 and x has power 1. A very simple way, just put the value of x 0, you will get y 0, 1, 2 and 3. Take a plain sheet, mark 1, 2, 3 on xy axis, take the corresponding values from this table, you will get a straight line. Also, this can be extended on the negative side. You can also plot some other graphs like y is equal to 3x plus 4 or x is equal to 3y plus 5. But in physics, just look at the Ohm's law. V is equal to IR. In 10th class, you have studied I is directly proportional to V. Okay. If I plot a graph between V and I, then this type of graph will be obtained. Let V on x-axis and I on y-axis. Be careful about what parameter you have to choose on x-axis. You have to choose that parameter on x-axis which is independent. Okay, so graph between I and V for Ohm's law is a straight line. Also, you can plot a graph between potential energy and the height. Let mg constant. Then you will see a graph between potential energy and height is also a straight line. There is a one more graph, y is equal to x square or y directly proportional to x square, or it can be under root of y is equal to x, or y has a power 1 by 2, x has a power of 1. Same for plotting the graph, you have to consider a table, you have to make a table, and then you will find this kind of a graph. So this graph is called a parabola. For example, the graph between kinetic energy and velocity is parabolic in nature. If I plot the graph on another side, if I put the value of x is equal to minus 1, y is going to be positive, because minus 1, the minus 1 square is plus 1. So you will get positive values of y. So this is the nature of the parabola. Okay, if you want to plot the graph for y minus x square, you will get graph like this. If you want to put x square is equal to y, there will be graph like this, and if you put x square is equal to minus y, the graph is like this. There are some more graphs. For example, y inversely proportional to x, or let us say constant of proportionality 1, y is directly proportional to x raised to power minus 1, or y is equal to, let us say, x to power minus 1. So same 0, 1, 2, 3, get the values of y. At 0 it is infinity, because 1 upon 0 is infinity, and for 2 and for 3. And be careful in choosing the values on y-axis. If you choose the same values as that of x-axis, then you will find very difficult to plot a graph. So on x-axis 1, 2, 3, 0.1, 0.2, 0.3. Why? Because there is the maximum value is infinity, and then there is a 1, and then it starts decreasing. So I make a choice of 0.1, 0.2, 0.3. Okay, so when x is 0, y is infinity, means it will not meet to the y-axis. So its a value at 1 is 1. So let us start our graph from this point. So you see this kind of nature. Okay, so this kind of nature, this kind of graph you can plot for resistance which is inversely proportional to the area. Okay, when we increase the area, resistance reduces, because it is inversely proportional to the resistance is inversely proportional to the area. So this kind of graph you observe. You can also plot the graph when y is inversely proportional to x square. You will obtain graph like this. You see this is little flat and this is little sharp, and if you are getting the values 1 by x cube or more, then definitely the graph will change. The very simple method is you just make always a table, put values, choose particular points on the axis and plot a graph. This kind of graph you will can obtain for Newton's law of gravitation, where F is equal to g m1 m2 by r square. Let us say g m1 m2 constant, and then F is inversely proportional to r. So this kind of graph is you can obtain for Newton's law of gravitation, and the parameter is force and the displacement. We will discuss now differentiation and integration. These are the two methods in calculus. Let us differentiate y with respect to x. Then its symbol is like this, dy by dx. For example, we generally say that the displacement upon time is velocity. No, it's not the definition. The definition is rate of change of displacement. So there is a change in displacement with respect to change in time. Rate means time. So this is dx by dt. So here we are differentiating the displacement or distance with respect to time to calculate speed or the velocity. We have the formula dx raised to power n by dx. Then keep your power here, means multiply it and reduce the power by 1. Okay, and keep one more thing, the differentiation of constant is always 0, means if this parameter is not depending upon x, then its value will be 0. Let us say one example, x is equal to 3t square plus 4t plus 5, where x is displacement and t is the time. Let us find its velocity. We know the formula, v is equal to dx by dt. Let us differentiate it. Okay, so open the brackets, you will get these terms. This is 0 because it's a constant. It has power 1, it has power 2. So 2 will come here and its power will be reduced by 1. Similarly, 1 minus 1. So you will get the value v is equal to 60 plus 4. We can also use one more formula in differentiation. If y is dependent upon x and there is a power of y, then you have to differentiate it one more time. Okay, n multiply, reduce the power by 1 and also differentiate this function separately. Now let us consider, let us take on integration. This is the formula. Let us integrate y with respect to x. It is of two types. Integration without limits is called indefinite integration, and with limits, if I put the limits of x a to b, then this is called definite integration. Its formula is this, that its power increases by 1 and in spite of multiplying the power, we divide here and plus it by 1. Let us use this formula. When velocity is 3t square plus t plus 5. Now we have to find out the displacement. If you are differentiating x, then you will get velocity. If you are integrating velocity, you will get displacement. So x is equal to integration of v dt. So let us integrate. So after integrating, where there is a power and nothing is written on the power t, it means this is the power is 1, and if t is not there like this, then you have to write t raised to power 0. Okay, because you know anything raised to power is 0 is 1. So use this formula, increase the power by 1 and divide power. Okay, so its power is 2 plus 1, 2 plus 1. Its power is 1, 1 plus 1, 1 plus 1. Power 0 plus 1, 0 plus 1. You will get this value. Sometimes we also use a constant where we want to define it. Okay, for example, in the radioactivity formulas, we use constant and then again we find the particular values. And for definite integration, manipulate the formula, change it like this. First put at the place of x b and then a, subtract them, keeping power same, means the formula is b raised to power n plus 1 minus a raised to power n plus 1 and divided by n plus 1. Let us again have a very simple example of velocity 3t square. Now we want to find the distance or displacement from time 2 seconds to 3 seconds. It means a has value 2 and b has value 3. So use this formula. 3 comes here, that is b, okay. And what is the value of a? The value of a is 2 and the power is also 2. So 2 plus 1, 2 plus 1, 2 plus 1. So you will get the value equal to be 18.